Charging by conduction. Fix the metal sphere Y to be charged on an insulating stand. Bring the charged rod X with a positive charge in contact with Y. From Y, some of the free electrons flow towards the rod X to neutralize the positive charge on it. As a result, there will be a deficiency of electrons on the sphere Y and surplus of positive charges. Thus, Y gets positively charged. As charging by conduction depends upon flow of free electrons, this method cannot be used to charge an insulator where the electrons are firmly bound. Charging by induction. In this method, electric charges are induced without the two bodies coming in contact with each other. Two metal cans A and B are placed on insulating tiles in such a way that the surfaces of the two touch. A positively charged body R is now brought near B. Keeping R in position, the can A is separated from the can B by moving the tile below A. While moving the can A, care should be taken that it is not touched. Then R is removed completely. Two natural charging by earthing process. An alternative method of charging body by induction is the earthing process. A positively charged acetate strip is brought near a neutral insulated conductor. The negative charge is attracted to the positively charged body at the end A, and the positive charge is repelled and collects at the end B. The conductor is then earthed by touching the end B with a finger. This closed path allows electron to flow from the earth to neutralize the charge at B. The acetate strip is then removed after the finger has been taken from the conductor. Now the conductor is left with a negative charge and it will get distributed on the conductor. You will notice that the kind of charge induced on the conductor is opposite to that on the charged strip. Induction in non-conducting materials. Electrostatic induction can also work in non-conducting or dielectric materials. However, movement of electrical charges is much more constrained in non-conductors than in conductors. If the non-conductors consist of polar molecules, for example, the water molecule has more positive charges on one side of the molecule and negative charges on the other side. Thus, water can be slightly attracted to a static electric charge. A demonstration of that can be seen in bending a stream of water with a charged plastic comb. Let us take an example. A polythene piece rubbed with wool is found to have a negative charge of 3 into 10 to the power minus 7 coulombs. Estimate the number of electrons transferred from which to which. Is there a transfer of mass from wool to polythene? Solution. When polythene is rubbed against wool, a number of electrons get transferred from wool to polythene. Hence, wool becomes positively charged and polythene becomes negatively charged. Amount of charge on the polythene piece Q equals minus 3 into 10 to the power minus 7 coulombs. Amount of charge on an electron E equals minus 1.6 into 10 to the power minus 19 coulombs. Number of electrons transferred from wool to polythene equals to N. N can be calculated using the relation Q equals to N into E. Therefore, the number of electrons transferred from wool to polythene is 1.87 into 10 to the power 12. Yes, there is a transfer of mass from wool to polythene. There is a transfer of mass taking place. This is because an electron has mass equal to m, E that is equal to 9.1 into 10 to the power minus 3 kg. Total mass transferred to polythene from wool is m E into n. That comes out as 1.706 into 10 to the power minus 18 kg. Hence, a negligible amount of mass is transferred from wool to polythene.